in video 2, where we do lots and lots of examples. And in this one, a road rises vertically over a horizontal distance of 40 meters. What is the angle of incline? Okay, well, if this is the ground, sort of sea level, and it rises 3 meters over a distance of 40 meters, what's the angle? So in other words, we're finding theta. So finding theta, so we're going to need to use the inverse function. So what have we got? Well, we've got the opposite and the adjacent. We don't have the hypotenuse, but we don't really need it, and we are looking for theta. So opposite and adjacent means we're going to be using tan. So tan -1, so theta is going to be equal to tan -1. Opposite over adjacent, and opposite is 3 over 40. We would put that in the calculator. So shift 3 divided by 40, 4.289 degrees. That would make sense. 4.29 degrees. And that's done. In this one, we're told that a kite string is 25 meters long and makes an angle of 37 degrees with the ground. How high is the kite? Well, really, what have we got? We've got the hypotenuse, don't we? And that's going to be 25 meters. So if the person is kind of standing here holding the string and the kite is kind of up here, and we know that this is 37 degrees, how high is it? So we're looking really for the opposite side. So we're looking for the opposite side. We don't care about the adjacent side. We've got the hypotenuse and we've got the theta. Hypotenuse and opposite means we're going to be using sine. We're not looking for the angle theta, we've already got it, so we're going to be using just the normal equation. So what are we looking for? We're looking for the opposite side. So we're going to move Dusty up here over the opposite side, and we can see from that that's going to be equal to sine of theta times the hypotenuse. So the opposite side, so let's call it the height, which is the opposite side, is going to be equal to sine of 37 times the hypotenuse, which is 25. We race to the calculator. So sine of 37 is that, times 25 is 15.05. Okay, 15.05 watt. Well, it gives it to us in meters, so our answer is going to be in meters. This one's an interesting one. A triangle has side lengths 7 centimeters, 24 centimeters, and 25 centimeters. Show whether it is a right angle triangle. Okay. So for this one, what are we going to do? Well, we know that in a right angle triangle, the adjacent side square plus the adjacent side square equals the hypotenuse side square. And the hypotenuse side is always the longer side, so the 25 centimeter side would be the hypotenuse side. And then let's call this one 24, and let's call this one 7. So just by looking at it, it's pretty unlikely that is actually a right angle triangle, but let's kind of make sense of it. If it is a right angle, triangle, a rat, then 24 squared plus 7 squared would equal 25 squared. And your alarm bell should be ringing. Yeah, it's obviously not. If it is greater than 25 squared, it's not. If it's less than 25 squared, it's also not. So let's work it out. Let's work out the left hand side and then work out the right hand side. So the left hand side is equal to 24 squared plus 7 squared is 625. Fair enough. The right hand side is 25 squared which is 625. Interesting. So therefore, yeah, it actually really is a right angle triangle. How about that? Another word question. The base of the ramp is 15 meters and it rises 4 meters. Find the angle of the ramp. I think this is fairly similar to the incline that we had before. I think isn't the base of the ramp the bottom bit that runs along the floor, isn't it? So that's 15 centimeters, and it rises by 4 centimeters. And then they want you to find the angle of the ramp, which is the angle of incline. So they want you to find theta. The fact that we're looking for theta means that we're going to be using the inverse laws. So we're looking for theta. We've got the opposite, which is 4, and we've got the adjacent, which is 15, running along the ground. We don't really care what hypotenuse is, we're looking for theta. Okay, so opposite and adjacent is what we're working with. So are we going to be working with sine? No. Cosine? No. Tangent is opposite and adjacent. So we're going to move Dusty here. No, we don't need to worry with Dusty because it's going to be incline. So the theta is going to be tan -1. Opposite over adjacent, the opposite is 4. And that's 15. We run and grab the calculator. So tan -1, 4 divided by 15 is, drum roll, 14.93 degrees. That's how it's done. Another kind of interesting one. A right angle triangle has an angle of 36 degrees. Okay, so our theta is going to be 36 degrees. And the hypotenuse of 10 centimeters. Find both the opposite angle and the adjacent angle. We can't do both at once. Let's find the opposite angle first. So let's find the opposite angle. So we've got the theta angle, we've got hypotenuse, we're looking for the opposite. Okay. So opposite and hypotenuse is going to be sine, and we are looking for the opposite side, so we're going to move Dusty up here. So the opposite side is going to be equal to sine of the angle, which is given as 36 degrees, times the hypotenuse, which is 10 centimeters, and the calculator will give us the answer as per normal. Sine of 36 is that, times that by 10, 5.88. Okay, we've got two of the sides now. Would we use Pythagoras' theorem at this point? In other words, square this number and square that number and subtract? And the answer is no, you probably wouldn't if you have a choice. The reason why is this is rounded. Okay, I rounded it to 2 decimal places, so it's actually 5.87785. The fact that we've rounded means that there's going to be a bit of error that creeps in if we use that. So let's just ignore the opposite and go straight to the adjacent. So if we've got the hypotenuse and the adjacent, CAH, we're going to be using cosine. We're looking for the adjacent, so Dusty jumps over here. So the adjacent side is going to be cosine of 36 times the hypotenuse side, which is 10. This is the formula here. And we run away to the calculator again. So cos of 36 is that, times that by 10, and it's going to be 8.09. And we're done.